everyone. Welcome to the episode on Oracle Cloud VMware Solutions. My name is Satya Shrestha, a senior staff multi-cloud solutions architect here at VMware. And I'm joined by Chris Bannayan, who is a cloud infrastructure specialist at Oracle. Welcome to the show, Chris.
Thanks, Satya. Nice to be on the show. And hello to everyone.
Chris, if you could briefly introduce yourself
to
our viewers, that would be really great.
Yeah. So my name is Chris Bannayan. I'm a part of the OCI infrastructure specialist team. Predominantly, I look at all things infrastructure and OCI, networking, security, storage, compute, OCVS as well. Oracle Cloud VMware Solution that we have, one of the products that I also support and SME on.
Excellent. Now, in today's video, Chris and I will be covering about what's new on OCVS service, OCVS being first-party solution from Oracle, and then Chris will be covering what are the new additions to OCVS. So Chris, to set the context to our viewers, why don't you quickly talk about what OCVS is, its value prop to our customers, and how our mutual enterprise customers are using it today?
Yeah, so what Oracle Cloud VMware Solution is basically running VMware inside the cloud on bare metal service. So from our perspective, when we talk about the benefits of OCVS, it's really taking what you have currently in an on-prem VMware solution and just extending it into the cloud. The management is seamless. You manage OCVS the same way that you manage VMware in your on-prem environment. It's highly scalable, it's highly configurable, and you have full control. You can scale and start anywhere from a 3-node to 64-node cluster for production environments. A unique capability of OCVS is you can also run a single node cluster for, say, dev test environments.
Nice.
So for production environments, as I said, it's highly scalable. We have a various options in terms of the compute nodes that you can use for your cluster nodes. Anywhere from 12 core per bare metal host to 192 cores per bare metal host. So it's massively scalable. You can utilize existing NVMe storage in the cluster nodes, or you can use OCI block storage service to increase your capacity. So from a flexibility and scalability perspective, we can scale using additional cluster nodes. But if it's based on capacity, so we can independently scale storage, for example, without having to add more cluster nodes, we can just use file storage from OCI, or we can use block storage from OCI. All the software components are included as part of the deployment. So when we deploy the SDDC, the software-defined data center, you get vSphere, you get HCX, you get NSX, you get vSAN. All those components are included as part of the deployment, and you manage them exactly the same way that you manage your on-prem environment. This is one of the key benefits of OCVS and OCI, is that because it's on bare metal, because it's running the same software, and you get the root password. The keys are handed over to you once we deploy the environment. You manage it, you upgrade it, you patch it exactly the same way that you would manage the environment. Because it also comes with HCX, you can start moving workloads and migrating workloads by using the HCX connector, pairing up the two sides from your on-prem into OCI, and from there, from your vSphere console, or vCenter console, it just looks like any other cluster that you've added in your on-prem environment.
Exactly. So it's basically your own data center, but it is in Oracle Cloud Data Center, which is highly performant on a highly performant bare metal instance, right? And then you do exactly what you do in your on-prem, but in Oracle Cloud environment, which is really enterprise grade, as well as now with OCVS sitting along with the Oracle excellent services. Now our customers can then start leveraging those OCI services as well, and then start modernizing their workloads, right?
Absolutely. And there's various workload types that you can use. So things like disaster recovery, lift and shift services, data migration, hybrid cloud solutions. So depending on the workload that you have, it makes a lot of sense to put OCVS environment in OCI. The other benefit is from a procurement lifecycle perspective, it takes 30 minutes to add a new cluster node to the environment. So as you scale up, you may have exceeded your thresholds for for workload, and your workloads are expanding. 30 minutes to add a new, or actually 15 to 30 minutes to add a new cluster node. And when you compare that to an on-prem environment, if you're procuring new hardware, we're talking weeks, potentially months, depending on the vendor.
Exactly.
Bring the hardware in, to include in your data center, to install it, attach to your network, operating systems, etc. So 30 minutes it's a pretty good thing to have, right?
Now today, what are our enterprise customers using in OCVS? Like, what are the applications that you usually see?
So there are customers using it for their own applications. So we've got some customers using it for bespoke applications, call center applications. There's customers using it for VDI. We have a customer in South Australia who's using it for development. The benefits they've seen from a development lifecycle perspective, that it's so much quicker to deploy the environment, to scale the environment, but also to back it up. And they've seen, because we can leverage all the 100+ OCI services that we have in the cloud.
Yes.
And present them to the OCVS environment. So you can consume things like object storage, block storage, file storage. So for backups, you can have your enterprise backup software, back up your entire VMware platform straight to object storage and OCI, or use it as basically a tiering model, right? So from your tier 1 could be block storage inside a virtual machine in OCVS, and then you can tier that off and go for standard tier, and then infrequent tier, and then say archive tier.
Got it. Got it. Use all the features and benefits that OCI provides.
All the features. And that's one of the big benefits is that because OCI is a zero trust model. So when you deploy the environment by default, you have access to nothing. No one can get in, no one can get out. You need to start opening up the services, access to those services from the networking perspective, opening up all the routing rules, the firewall rules, the security aspects of it all. And then you can start accessing either its resources inside OCI, resources in the on-prem environment. So typically you connect to a OCVS on OCI using a Fast Connect. So Fast Connect is similar to an Azure Express from Azure. It gives you that private dedicated link. So that way you've got that seamless access between your on-prem environments and OCI.
High bandwidth, low latency connection.
High bandwidth, low latency, correct. Up to multiple 100 gigabit links per second for a Fast Connect. But you'd also use things like VPN, right, for dev test environments.
Excellent. Thank you, man. That was awesome premiere on what OCVS is and what the value proposition it has, right? Okay, let's get into our today's topic, which is what's new. So tell us what is exactly happening with OCVS.
So let's have a look at what are the new things that we've come up with. So as I said, VMware is really, on OCI is just VMware. You manage it like you would, but we're moving to vSphere version 8 or ESXi 8, vCenter 8, NSXT 4, vSAN, and HCX Advanced 4.51. So these are the softwares that get included as a part of the deployment for OCVS. As I said, there is no additional cost for these licenses. It's all included as part of the cost of deploying OCVS inside OCI.
Right.
It's highly scalable, as I mentioned. So we start with a minimum of 3 nodes, 36 cores to 384. So that 36 cores means we can start as low as 12 cores per server. So this is we used to start at 32 cores. So we reduce that core count to give you a lower TCO, basically a lower entry point into OCVS. So you can start small. We can go from anywhere from 2 to 6 terabytes of memory in some of the newer, the E5 shapes that we just released, which is the AMD EPYC 3rd generation metal host that we can now use as part of OCVS. We can scale up to 192 cores and 2.3 terabytes memory on a single node, which is massively scalable, right? As I mentioned, leveraging OCI iSCSI block storage, attach that to the cluster, and then using that, for example, instead of vSAN, right? vSAN comes by default on some of so we have 2 types of shapes inside OCI for OCVS. One is a standard shape and one is a dense IO shape, which is the original shapes. And the dense IOs come by default with NVMe storage. So 8 NVMe storage SSDs, up to 54 terabytes of storage per node. And that builds a vSAN across those cluster nodes.
Right. So they can directly have that block storage as a data store, right? And then they can start having their resolutions and all the workloads there. Okay.
Absolutely. Right. So you can create your data stores out of the existing, out of the iSCSI block storage service, which is, again, fairly different to some of the other hyperscalers and how they implement VMware. We can also leverage our file storage services. So NFS and creating data stores on our NFS platform.
So when would a customer use OCI block storage as data store, and when would they use vSAN as data store? Is there like a specific use cases they should be using it for?
Look, from a performance perspective, it's really quite close now. Now, because the NVMe SSDs came out with our 1st generation bare metal hosts, right? And by default, you would get, as I said, 54 terabytes per node. But there was additional cost associated with that because you're using 50 odd terabytes of NVMe. The standard shapes now, because we can start as low as 1 terabyte.
Right. Okay.
Right. So we've reduced the need to use vSAN by using block storage. We've reduced the core count from 32 to 12 cores. So now you can start much smaller. So
entry point is much cheaper.
Cheaper and start small and then grow into a larger configuration, more powerful.
Got it.
Performance perspective, block storage in OCI is highly performant. We can start as low as 6,000 IOPS or even less per gigabyte per volume. Or we have the concept of VPUs, volume performance units. But we can get up to 300,000 IOPS at 2.6 gigabytes per second per volume. So volumes attached to an OCVS cluster. The current limit is 8 nodes per cluster in terms of accessibility to a volume. So shared cluster volumes. That's now increasing to 32. So we can have 32 cluster nodes sharing a single volume inside OCI.
Nice, man. I really like the flexibility. You use vSAN if you really have, for example, database workloads, which needs massive IOs, right? And if you have analytical workloads, probably use OCI blocks. So, I mean, it's all depending on what architecture you have, what performance you need, right? So I like the choice and flexibility you guys have. It's good.
Yes, that's sort of where we're aiming at, to give the customers that flexibility, to be able to start at smaller workloads and scale up to larger workloads, start at lower capacity performance workloads, and then scale them up. And the scaling that we have with our storage is online. So create iSCSI, ingest iSCSI configuration, attach those volumes to OCVS. We can start a balanced IO performance VPU of 10. So we can scale that online in real time and up to 120, which gives you that full 300,000 IOPS.
Nice. Without any downtime. It's just
without any downtime. Absolutely. Without downtime.
I like it. A quick one on this vSphere versions here, right? So you said before we had vSphere 7 that comes as bundled, like in original form.
Yep.
Now, every new instances you can launch as vSphere ESXi 8, is that right?
Correct. You have two options. So you can still install the OCVS environment either with version 7 or with version 8 now, right? As I mentioned earlier on, because now you own the platform, when you install with version 8, you can patch it. You do the lifecycle management of that in those cluster nodes yourself. So you can patch them when you want. All the security patches, the software updates, etc., all managed by you. We give you the root access to the environment. You own those cluster nodes now. They belong to you. You own the keys to it. You can basically manage it the way you would manage your on-prem environment.
Absolutely. And if a customer is already using vSphere 7, for example, how would they go to ESXi 8? What is the method for that?
So typically exactly the same way as you would upgrade your environment now. Right? So if a customer has an on-prem environment, they want to move from version 7 to 8, you would use, download the patches or the software updates from VMware. Exactly the same method. We do the exact method inside OCI. If you're deploying a brand new environment, then you just select the software version that you want and deploy SDDC with those versions.
Okay, that's very neat. I like it. All right, let's move on to the next one. What's the next update we have? Yeah.
This slide is really showing us the different options in terms of shape. And when we talk about shapes in OCI, it's the configuration of the hardware. So on the left here, we have a dense IO shape. So these are the original shapes that we introduced when we brought out OCVS. And you can see here we've got Intel shapes and we've got AMD. So Intel X7, which is based on Skylake, 52 cores per node, 768 gigabytes of RAM, and 50 odd terabytes of NVMe. The AMD E4, which is the third gen EPYC, up to 128 cores, 2 terabytes of RAM per host. So more scalability in the host and a bit more cost effective, right, from an AMD perspective. And again, you get that 50 odd terabytes of NVMe storage.
Right.
These came as vSAN, so these were vSAN configured customers, right? So because they had local NVMe storage, we would use vSAN to configure that and then increase the vSAN pool as we added more cluster nodes to the environment. Your vSAN pool would increase. But we can also add block storage to that. If you just needed to increase your capacity on these nodes, there is no need to put another cluster node with more CPU and memory. You just want to add more capacity. We just configure OCI block storage, attach it to these nodes, and create a new data store using those block volumes. Now, with these new shapes called the standard shapes, we no longer have internal NVMe drives. It's all using OCI block storage. So there's no vSAN, but you can start, again, as I said, very small. So the X7, again, we start at 12 cores up to 52. The X9, we go from 16 to 64. The AMD E4 from 32 to 128. And now we've got the new AMD E5, and we go from 32 to 192. Right.
So this one has no vSAN at all. So it's
no vSAN. No vSAN. It's just using iSCSI for data stores.
Okay. Are they cheaper in terms of prices as compared to the previous gen?
So because you can start smaller, it becomes cheaper. Right. So here we start at 32 cores and 52 cores with the Intel. There's no lower entry point. So the cost is a little bit higher. With these new shapes, you can start at 12 cores. So we're reducing the cost drastically. And because we can start with almost 1 terabyte of storage, again, our costs start very low. You may not need 50 odd terabytes of NVMe.
Yes.
You may just need 5 terabytes of NVMe to start off with. So you can start small and then grow into it. As part of some of the new services now and features of OCVS, we can start small. We can mix and match nodes. So previously, we wouldn't mix and match. Say, if you had a 3 by 32 core node cluster using AMD E4s, you couldn't add, for example, a 64 core node. It has to be the same type. But now we can, right? So we can have 3 nodes with 12, we can add a 4th node with 38, or we can add a 4th node with 48 CPUs.
Nice.
So we can mix and match the actual image types, the shapes of the images to give you that scalability. We can also now have different cluster configurations inside a single SDDC. Right? So you can have one SDDC and you can have multiple clusters inside that SDDC and have clusters of different shape configurations. So I can have a 3-node, 12-core cluster for some of my lower-end workloads. And up with a 3-node, 128-core cluster in the same SDDC for some of my, highly scalable, highly performant applications.
Right.
But that's also a new feature that's added, which is multiple clusters inside an SDDC.
So this new shape AMD E4, what is the difference between that and the previous AMD E4 host?
So these shapes are the same. This E4E in the standard and the E4 on the dense is the same. The new one that we've added to the standard shapes is going to be the E5.
Oh, okay.
So will there be a new E5? Which is, again, using the 3rd generation EPYC, but it's now more scalable. As I said, it goes to 192 cores, and it goes to 2.3 terabytes of RAM.
Right, okay, got it.
AI is prominent at the moment in the media. Everyone's talking about AI and generative AI and all sorts of AI workloads. So we've released new GPU shape configurations that we can now add to OCVS cluster nodes. So if you require, GPUs inside your cluster nodes for maybe VDI workloads or any type of other workloads, we can actually now attach GPU processors to individual cluster nodes, you can actually configure it so you can split up the processing power of the GPU and allocate it to multiple virtual machines. So they're all sharing one GPU, or you can have one GPU allocated to one virtual machine. So it's highly configurable. So if you want a really high performant GPU workload on a specific virtual machine, you can keep it that way as well.
Okay. So this is in the initial tech review mode at the moment.
Correct.
Yeah. Okay.
Now, as you can see here, this is really slide just gives you an idea of how the NVIDIA virtual GPU configuration stands. So this is on the left-hand side is CPU-only virtualization. So typical deployment of OCVS without no GPU. So we're relying on the server, the hypervisor, and the apps and VM sitting on top of that hypervisor. With adding the GPU, we have this virtual GPU network sort of layer that coincides inside with the actual VMware platform. And this is where we can now carve off some of this GPU's performance and allocate them either to a group of virtual machines or to a single virtual machine to get all the performance that you need out of that GPU. It just depends on the workload you want and you're deploying on the OCVS platform.
So this is much more cost effective as compared to the dedicated GPUs, right?
Yes. Yeah. I mean, you can have dedicated GPUs, but you can also share the GPUs as well.
Yeah, got it.
As I said, it's very flexible in terms of how we can deploy the OCVS platform. So previously, when we rolled out a single SDDC, which is a software-defined data center, we could only deploy one cluster in there, right? And that cluster was fixed in terms of the shape configuration, the number of cores, etc. It was sort of a little bit unflexible, but we've come a long way since we released OCVS. So now we can mix and match core types, and there is other features coming out which I can't talk about now, which again will be quite nice to viewers. In this deployment now, in some of the new features, we can create multiple clusters of different CPU configurations. Like you can see here, we've got one SDDC. We've got our overlays in terms of our software-defined products that gets installed as part of the SDDC. So NSX overlay, the vSAN, HCX, etc. that sit inside the OCVS deployment. And then we can have multiple clusters now.
And then these clusters could be like a different node type, like you said, right?
Absolutely. So cluster 1 is using dense shapes. Cluster 3 is using standard shapes. Cluster 6 is using GPU shapes. Right. Inside a single SDDC. So
within a cluster also, did you say earlier that even within a cluster we can have different nodes?
You can have different nodes of different core type configurations.
Right.
So for example, in this cluster 3, I've got standard shapes.
Yes.
I can have 2 of the nodes can be 16 cores. The third node could be a 64-core node.
Right, but it has to be standard shape, right?
Has to be standard shapes. Yeah, the dense IO shapes need to be dense IO shapes.
But the core count could be different. Got it.
Yeah, but the core count can be different. And same with the standard shape. The standard shapes need to be standard shapes in the same cluster. You can't mix a standard shape with a dense IO shape in a cluster.
Makes sense.
So we're also now extending support to having VMware Cloud Director Service sitting on top. Right, so VMware Cloud Director Service obviously is used to sort of give you an overview, an overall management in terms of your clusters, whether on-prem or in the cloud. It's used on AWS and Azure and GKS on their VMware platforms, but now we have it on top of OCI. So you can leverage OCI, the VMware Cloud Director platform, to give you more of a centralized view of all your VMware environments and allow you to manage them, say, one single point, one pane of glass.
So this is mainly for multi-tenancy, right? If you want
multi-tenancy environments, correct? Yeah.
So if you have multiple, same enterprise customer who wants a multi-tenanted environment, for example, one for sales, one for marketing, one for HR, or different use cases, right? So they can have this layered on top with VMware Cloud Director, and then they can serve those departments or customers.
Absolutely. Yep. Correct.
This is good. How about our partners? Are any of our joint partners using this? Because usually I see it mainly used by our partners too.
So I'm not sure of how many of our partners are actually using this because it's fairly new in terms of a new release. Because it's just been released, I don't think any of our partners would have actually leveraged this service as yet.
Yes.
But we are working. We do work very closely with some of our partners on recent VMware opportunities.
Yeah.
And we're always positioning the right products because a lot of our customers want central points of management, integration with some of the other features and functionality in VMware, right? Especially from a monitoring and management perspective.
Yes, makes sense.
So as I said, this is the AMD E5 shape that's to release.
Right.
So you can see it's highly scalable, highly performant, 192 cores, 2.3 to 2.5 terabytes of DDR5 RAM. But again, this uses block storage as well. So block and file storage for our data stores.
Right.
And some of the pricing. So pricing is flexible. You can either lock it in for a year or 3 years for your main production cluster. But if you needed an additional node because of a burstable workload that you may maybe once a month or whatever, then you can add a new cluster node, which takes 15 to 20 minutes to actually add another cluster node to the environment. And then you can do hourly-based pricing on that cluster node. So it gives you a better TCO, right? You're not paying another 1 or 3 years licensing. You're not locking it in for that period. You just want to say, I just want to use this node for 5 or 6 hours, get the workload, finish your workload, make sure it runs correctly, then you can scale it back down again, right? Remove that custom mode configuration.
This is the pure cloud elasticity.
Yes, it's showing the real dynamic elasticity of the cloud functionality and the way we can scale up and scale down quite nicely and independently. Again, it just depends on what your scalability requires. If it's CPU and memory, then yes, we add another node. If it's capacity or IO, then we just add more either block volumes or we scale up those block volumes in terms of performance.
Right. So one thing I also wanted to ask you about was our recent Canberra data center launch. Can you speak about, what is that and why it is important to our customers having the Canberra data center on OCVS?
So the Canberra data center is really for government. So it's GovClouds. It's government customers, government organizations. So we're giving them that ability to run OCI for their workloads inside Canberra.
Yes.
So it really is only for government customers at the moment, but it does give them the option to say now, put their workloads in OCI in a secure government DC.
Right.
Because some of them have, data sovereignty rules, etc. That may prohibit them from using public cloud for putting their workloads in, opening up this third data center. So this is our third data center now in ANZ, Sydney, Melbourne, and now Canberra.
Right. And then in terms of data sovereignty, I know government workloads are really restricted, right? So how is the uptake of that Canberra region at the moment?
So it's just been released. We have a lot of customers interested in it. So I guess that's all I can say at the moment is there is quite a few customers that are interested in it. We're having some good conversations. I think it's going to be very popular in terms of for us to have that presence down there because a lot of our customers are asking for it. And we do have quite a few customers now in Canberra. So given the option to use that data center is as production or for DR, we're doing that for a hybrid type cloud configuration where you move your DR component of your production environment in Canberra into the DC for DR.
And this is online today, right?
This is online, correct.
Got it. Awesome, man. I really like it. Yeah, this is great, Chris. Lots of great additions there on Oracle Cloud VMware Solution, right? And then we are jointly coming up with lots of new solutions, which is I really like about partnership with Oracle. Really appreciate your time today, man. And then I'll look forward to doing this more often.
Thanks, Satya. Pleasure being here.
Yeah, so thanks, Chris. I really appreciate your time today. And also thanks to our viewer for sticking with us until the end. And we look forward to seeing you again in our future videos. Thanks, and
enjoy.
Bye for now.
Bye-bye.